So hi everyone. So this is the lesson one of the logistic regression model series. Before delving into the logistic regression, it's necessary to understand why exactly the linear regression is not suitable for classification problems. What are those exact challenges? And then we will try to solve them step by step to reach the logistic regression model. So this lesson one will only focus on providing the motivation for logistic regression. So here is the agenda for this lesson one. So first we'll see a brief recap of linear regression, and then we will understand what are the issues if we use linear regression for classification problems, and then we will see how these problems are addressed by logistic regression. Then we will introduce the logistic regression. Here we will see why exactly we use sigmoid function with logistic regression. So this lesson is going to be very important for the data science interviews also, because it is often discussed in the data science interviews that why do we use sigmoid function for logistic regression, why not some other function, and so on. So let's begin this now. So let's have a recap of linear regression. So in linear regression setting, we have a set of independent variables called x, a target variable called y, which is also called a dependent variable. And these x's or the independent variables could be numerical, categorical, or anything. But this y would always be a continuous variable. So technically, when we have more than one independent variables, this is called multiple linear regression. And when we have just one feature, one independent variable, then this is called simple linear regression. So let's see this through an example. Let's say we have a small data set where we have hours of study and marks. So this hours of study essentially denotes, let's say, the average number of hours a student studied throughout the year, and marks denote the final marks he or she obtained in the final examination. So in this case, what we essentially try to do is we try to fit a best fit line which um, satisfies certain criteria, and the criteria is essentially that this distance, these distances, so this distance, and let's say this distance, and all of these distances. So sum of squares of all of these distances should be minimum. And once we have this best fit line, we can simply predict the marks basis number of hours he or she studied in the throughout the year. All right. So to obtain that best fit line mathematically, we assume a linear relationship between x and y, right? And how do we express that linear relationship? By this hypothesis, right? Which essentially looks like a simple mathematical equation of a line, which we have seen in our 10th standard maths, which looks like y equals to c plus mx, right? Where this theta naught is the intercept of this line on the y-axis, essentially this distance, and theta 1 is nothing but the slope of this line with respect to the x-axis. Now just a point to highlight here is that when we assume this relationship between x and y is linear, it does not necessarily mean that this has to be a straight line. This could be any other curve. It could be non-linear curve also, but that relationship should be expressible through this linear form of the hypothesis, which means these parameters theta naught, theta 1, they should be in their linear form. So I'll be explaining this part or this concept um, thoroughly in the later videos, but for now, you just need to assume that whatever relationship we assume between x and y, that should be expressible through a linear form of hypothesis. So once we have our linear regression hypothesis in place, the next question is how do we estimate the parameters? That means how do we get the values of these theta coefficients? So to estimate the parameters of any machine learning model, all we need is just three things. One is the hypothesis, second is the cost function, and the third is optimization method. So hypothesis we have already seen, right? For each data point, let's say xi, yi, where this xi is a single value in case of simple linear regression, and this xi would be a vector in case of multiple linear regression, and yi would be a single value, which is called the target value. And by passing xi to this hypothesis, we get the h theta xi as the prediction from the model or from the hypothesis. Now we also need a function or a metric which can evaluate the goodness of this hypothesis, right? Basis the theta values. So how do we define the cost function? We simply take the difference of the prediction from the actual value and sum it over all the data points, right? So this difference or this distance is nothing but this distance, right? And this cost function is called least squares cost function. And this optimization method is nothing but a way to minimize the difference between h theta xi and the yi by simply adjusting the theta values. In case of linear regression, there are two ways to do this. One is via normal equation, where we essentially have a closed form solution, and the other way is the GDT method, right? So we'll not go into the details of these methods here because we will only be focusing on the logistic regression part, not the linear regression.